So the next topic which we are studying is Prevost'S theory of heat exchange. Clear, ma? So it says that there will be exchange of heat energy continuously between one body and another body. Or you can say between one body and surroundings. Continuously there will be heat exchange. So one body will be giving heat energy. Similarly, it will be receiving heat energy also, either from the surroundings or from other body. So this theory is called as Prevost's theory of heat exchange. And this exchange of heat energy will continue until a thermal equilibrium is established between them. What is meant by thermal equilibrium? Both of them, they should be at same temperature. So until bodies are at same temperature, this exchange of energy will continue. Clear? Now see, so all the bodies at temperature above 0 Kelvin, 100% they will emit radiations. What is meant by 0 Kelvin? 0 Kelvin means minus 273.15 degree Celsius. No? So at this temperature, energy of every body will become 0. Okay? Translational energy, vibrational energy, rotational energy, heat energy, every energy will become 0 at 0 Kelvin. But above 0, that is even at 1 Kelvin also, body has some energy. And because it has some energy, it will be emitting the radiations. Understood, Nama? So every body above 0 Kelvin, continuously they will be emitting the radiations, whatever may be the surroundings. Amount of radiation emitted increases with temperature. So if temperature is greater, that body will emit more radiations. Clear, Nama? So there is a continuous exchange of heat energy between body and the surroundings. So the rise or fall in temperature of body depends only because of this exchange. If received energy is greater than emitted energy, then what happens to temperature? Temperature rises. Are you able to understand, ma? Received energy is less when compared to released energy. Then what happens? Temperature falls down. That is what happens. And until this thermal equilibrium is achieved, this exchange of heat energy will continue. Clear? Okay. So next we study about Kirchoffs laws. So what is meant by Kirchoffs law? It says that the ratio of emittance of a body to the absorptance of a body is constant for any type of body at a particular temperature. Are you able to understand, ma? And that ratio is exactly equal to emissive power of a black body. Are you able to understand, ma? So therefore, what is the ratio I am taking? Emissive power of a, emissive power to the absorptive power of any body. Whatever may be the type of the body, whatever may be the color of the body. Okay? So E by A ratio for any surface, it always remains equal to any other body. For example, if you take one body, E by A ratio, you take another body and you take its E by A ratio. They will remain same. And they will be equal to emissive power of a black body. This is called as Kirchoffs law. Okay, now see, for example, if I take one body whose emissive power is maximum. Okay, ma? So then E by A ratio should remain maximum, no? Okay, so therefore, absorptive power also should remain maximum. Are you able to understand? This is what we understand, Noma. For a particular body, if emissive power is greater, then its absorptive power also should be greater. Then only E by A ratio will be equal to another body. Okay. For example, if I take for another body, okay, ma? So emissive power, let us say it is very less. Clear? Therefore, what about its absorptive power? Absorptive power also will be very less. Okay? Because what is the ratio of these two? That should be equal to the ratio of these two bodies. So if emissive power is greater, absorptive power also should be greater. That is how we write the ratio. And all these ratios, they will be equal to the emissive power of a black body. Are you able to understand, ma? Come on, make a note. So the next law which we are studying is Stefans law. See, ma, here, for example, this is a heated body. Okay? This is a heated body. Are you able to understand? So heated body means it will be emitting radiations, no, ma? It will be emitting heat waves. Okay? That means it is releasing heat energy into the atmosphere. Okay? And that emissive power of any body is directly proportional to fourth power of its temperature. Okay? Temperature of the body, if it is T, then emissive power is directly proportional to what? Emissive power is directly proportional to T power 4 for a black body. Are you able to understand? Okay, ma? So this is the relation which is satisfied for a black body, ma. For a black body. For general body, we have to write E is proportional to emissivity multiplied by T power 4. This is how I can write for general body. Are you able to understand? Clear, no? Now see here. So first of all, we do calculation for a black body. So emissive power is directly proportional to fourth power of temperature of a body. Understood, no? Emissive power can also be written as Q by A into T. Already we have written, no? Total emittive power, or total emissive power, or total emittance is equals to Q by A into T. If I want to spectral emissive power, then it is different. Or monochromatic emissive power means in the denominator I have to write lambda also. Here we are not writing lambda, we are taking total emissive power. Okay? So therefore Q by T is directly proportional to T power 4 for a black body. So therefore Q is proportional to A into T multiplied by T power 4. Here capital T indicates temperature, small t indicates time. Are you able to understand? So therefore, if I want to write a general equation, then this is the general equation I can write by removing this proportionality symbol. And the values and the constant of proportionality is what here? Constant of proportionality is sigma. Are you able to understand, ma? And this sigma is called as Stefans constant. Okay? And if it is a general body other than black body, then I have to include emissivity also. Are you able to understand, ma? But this equation you can write for any body, whether it is a general body or whether it is a black body. Because emissivity of a black body is 1, no? Emissivity of a black body is 1. So you need not to worry about the equation. So this is the equation which you should remember. So the amount of heat energy radiated out of a body is equals to sigma EA T power 4 multiplied by T. Or you can do one thing. So this T, if you take to the other side, then it is Q by T, Roma. Energy per unit time is called what? Power. Power can be written as sigma EA T power 4. So this law we can call it as Stefans law. Okay, ma? Make a note. And here sigma value is this much mass. Sigma is called Stefans constant, the constant of proportionality. And it is equal to 5.67 multiplied by 10 power minus 8. That is the value of sigma. Clear, no? So very important, Lama. Many times questions were asked on this relation. And if question is asked on Stefans law, very easily you can do the calculation. Okay? So for other bodies, this emissivity is less than 1 ma, but for black body emissivity is equal to 1. So if he says perfectly black body, then immediately you have to understand that emissivity is given as 1 and you have to do the calculation. Understood, no? That's it. Okay. So see this question. So an electric heater of surface area is given, ma. This is the surface area of the heater, 200 centimeters square. So it emits energy of 60 kilojoules at the time interval of 1 minute. In 1 minute it is releasing this much energy and it is having this much of surface area. So determine its emissive power. That is the first question, no? First of all, let us do the first question. So emissive power. What is meant by emissive power? Do you remember, ma? Q by A into T, no, ma? Amount of energy radiated per unit area per unit time is called E value, emissive power. So energy is how much? 60 kilojoules. So 60 into 10 power 3 joules divided by surface area. It is given in centimeters square, no? So 200 into 10 power minus 4 meters square multiplied by time taken is 1 minute, no, ma? 60 seconds. If you do this total calculation, you will get emissive power. Let us see what is the answer he gave. So emissive power is 50 kilowatts per meter square. Okay, ma? So 50 kilowatts per meter square. This is the emissive power which we got. Okay? Now listen. So emissive power we have calculated. Now see. Now what is the question he is asking? Let us see, ma. Emissivity of this body is 0.05. Okay? Emissivity is 0.05. Then what is the radiant energy emitted by a black body in a time of 1 hour? That's the question he is asking. First, let us see the data which is given, ma. Emissivity means what? This is the symbol, no? Emissivity means emissive power of any body to emissive power of a black body. This is called emissivity. No? Understood, no? So he is asking question on black body, no? So you do one thing, you calculate the emissive power of a black body first of all. How can I calculate? So emissive power of a black body is equals to emissive power of body divided by emissivity. Emissive power already I have calculated, no? 50 divided by emissivity is already given as 0.45. Okay. If you do this calculation, what I will get? I will get emissive power of a black body. Okay. Now let us see what is the data he gave. Emissive power of a black body 111.11. 111.11. So kilowatts per meter square. So this is the emissive power of a black body. Why we have calculated emissive power of a black body? Because he is asking radiant energy, no? Okay, Subaka, Vinandi first. He is asking radiant energy. Radiant energy means what? Q value he is asking. For what? For a black body. So emissive power of a black body already I have calculated, no? So what is emissive power of a black body? Again same formula. Q by A into T. That's all, no? And he is asking Q. Radiant energy means Q only, no? So therefore Q value is equals to emissive of black body multiplied by A into T. So just do this calculation. So emissive power of a black body is how much? 111.11 multiplied by area is what? Area is same 200 into 10 power minus 4 multiplied by he gave in 1 hour. 1 hour means 3600 seconds. So do this calculation. That will be the energy radiated by which body? Black body. Is it clear? Very simple. So therefore 8000 kilojoules of energy. 8000 kilojoules of energy is radiated by black body. So have you understood the method of calculation, ma? First we have calculated emissive power, and we know emissivity is already given, no? From that I have calculated emissive power of a black body. Once I calculate emissive power of a black body, then I can calculate energy released by black body in a time of 1 hour. That's it. So let us see this question. See what is the data given here. Okay. So operating temperature of an incandescent bulb is 3000 Kelvin. This is the temperature at which a bulb is glowing. And how much energy it is releasing per second? 60 joules of energy per second. It means power is 60 watts. Surface area is also given. Then we are supposed to find out emissivity. That is the data, no? So it means what are the terms which are given? Power is given, temperature is given, emissivity I have to calculate, surface area is given. These are the values which are given, no? And all of them, they are present only in Stefans law. What is Stefans law? Power is equals to sigma EA T power 4. This is the equation, no? Clear, no? Just substitute in this equation. He is asking us to find out emissivity. So E is equals to P divided by sigma EA T power 4. Power is how much? 60 watts. Given in SI system, you need not change it. Sigma, already we have calculated now, 5.67 into 10 power minus 8. Surface area 25 mm square, so 25 into 10 power minus 6 meter square. Temperature is how much? 3000 Kelvin, so 3000 power 4. That's all, number. So if you do this total calculation, you will get emissivity of this particular bulb. And the value which he gave is 0.52. If you do this total calculation, you will get 0.52. That's it. Clear, now? Very simple calculation. Sima. So let us see what is the data given in the question, ma. So brass sheet. Brass sheet means what? This is a rectangular sheet, no, ma? Okay. A sheet, or you can call it as a lamina. Sheet also can be called as a lamina, no, ma? A sheet of paper or sheet of metal. So sides are 15 centimeter, and this side is how much? 12 centimeter. This is the given data, no? Now in this condition, how can I calculate area of this sheet? Anybody? Area is length into breadth, but this is not correct. Why? Why it is not correct, ma? See, ma, this brass sheet, when it is heated, it will radiate energy from both sides, no? From the front side also it will give energy. From the back side also it will give energy. So total area will be 2 into L into B. That is the area here. Are you able to understand, ma? Because sheet has two surfaces, no? Sheet has two surfaces, no? Front surface also, back surface also. From the front surface also it is radiating energy. And from the back side also it is radiating energy. Okay. So therefore do the calculation. 2 multiplied by length is how much? 15. So 15 into 10 power minus 2 if you convert into meters. And breadth is 12. 12 into 10 power minus 2 meters. So therefore total how much it is? So 182 is 360. So 360 into 10 power minus 4 meter square. So this is the area of the sheet. Understood, Nama, why we have taken 2 here? Because it has two surfaces. Energy radiated surface only, now I have to take. Energy is radiated from both surfaces. So its effective area will become 2 times the surface area. Okay, ma? Now see what is the data still he is given. Temperature is given, and how much electric power is needed to maintain the sheet at this temperature. So what is the meaning of this one? What is the energy radiated? Same energy you have to supply also, no, ma? For example, it is losing 10 joules of energy per second. How much energy you have to supply? 10 joules. Then only it will maintain its temperature. Are you able to understand? Adi anta energy loss avutundo, anta energy ni meeru supply kuda cheyali. Therefore, given that its emissivity is 0.025. It means question is directly given on Stefans law. Okay, power is equals to sigma EA T power 4. Okay, ma? So power of electric heater, it means you need not change anything. Sigma value is 0. Sigma value is Stefans constant, 5.67 into 10 power minus 8. Emissivity is how much? 0.25. The area already we have calculated, 360 into 10 power minus 4 multiplied by temperature is 600 degrees Celsius, no, ma? So 600 plus 273. I have to convert into Kelvin scale, no? Okay, ma? So therefore 873. So 873 power 4. So do this calculation, then you will get the required amount of power of the heater. Understood, no? And the answer should be 296.4 watts. 296.4 watts. That should be the power of the electric heater. Okay?